Hello everyone and welcome to our channel Mootechie. Let's dive straight into our topic for today, electrochemistry. Now let's understand what an electrolyte is. An electrolyte is a substance that can conduct electricity when it is in a molten state or in an aqueous solution and undergo chemical changes. So a liquid is an electrolyte if, first, it contains charged particles which are typically ionic compounds, and second, its charged particles are free to move through it. Electrolytes versus non-electrolytes. Moving forward, let's clarify when a substance is an electrolyte and when it is not. A substance is an electrolyte when it is a solution, aqueous, dilute, dilute, or a molten form of ionic substances. On the other hand, a substance is a non-electrolyte when it is glacial, pure, or anhydrous, even if it's an ionic substance, or when it is simply a covalent compound. Examples of electrolytes. Next up, let's look at some examples of electrolytes. These include molten salts, like molten lead-3 bromide, a solution of salt in water, such as sodium chloride solution, a solution of acid in water, like aqueous hydrochloric acid, a solution of alkali in water, such as aqueous sodium hydroxide. But wait, there's more. Metals like aluminium, zinc, and copper can also conduct electricity, but they do so without undergoing a chemical change. Other electrolyte examples are copper-2 sulfate solution (VN), aqueous argentum sulfate (HA), and dilute zinc nitrate. Now, imagine a diagram here. We see a circuit with batteries connected to an ammeter and two electrodes dipped into a beaker labeled electrolytes. Please notice what happens to the ammeter. The needle moves. So what made the needle of the ammeter move? We'll come back to that soon. Examples of non-electrolytes. Let us now look at non-electrolytes. A non-electrolyte is a substance that cannot conduct electricity either in a molten state or in an aqueous solution. They cannot conduct electricity because they do not have any ions that are free to move. Examples of non-electrolytes include sulfur, wood, naphthalene, sugar. Other examples are pure ethanol, POITs, glacial ethanoic acid, latex, POITs, and glucose. Now, picture another diagram. This one shows a similar circuit setup, but this time the beaker is labeled non-electrolytes. Please notice what happens to the ammeter here. The needle of the ammeter did not move. Why do you think that is? It's because there are no freely moving ions to carry the electric charge. The secret: freely moving ions. So what is the secret behind an electrolyte's ability to conduct? It all comes down to freely moving ions. When the ionic bonds in a compound are broken, either by melting or by dissolving in water, positive and negative ions are released and can move freely. When electricity flows to the electrodes, positive ions called cations are attracted to the cathode, and negative ions called anions are attracted to the anode. The flow of electrical charge is carried by these ions within the electrolyte and by electrons in the connected wire. This is why an electrolyte with freely moving ions is able to conduct electricity. Let's go back to that first diagram with the electrolytes. What made the needle of the ammeter move? It was the presence of freely moving ions in the solution that completed the circuit and allowed current to flow. Cations and anions. Now let's talk about the ions themselves. We have anions and cations. Ion type: charge, attracted to. Examples: anions, negatively charged particles. Anode, positive electrode, nitrate ion, NO_3 to the power of minus. Sulfate ion, SO_4 to the power of 2 minus. Chloride ion, Cl to the power of minus. Iodide ion, I to the power of minus. Bromide ion, Br to the power of minus. Carbonate ion, CO_3 to the power of 2 minus. Cations, positively charged particles. Cathode, negative electrode, sodium ion, Na to the power of plus. Copper-2 ion, Cu to the power of 2 plus. Copper-1 ion, Cu to the power of plus. Aluminium ion, Al to the power of 3 plus. Magnesium ion, Mg to the power of 2 plus. So what have we learned today? Let's recap with a simple mind map. We covered electrolyte, non-electrolyte, and the crucial role of freely moving ions in conducting electricity. Thank you. See you in the next class.